Alright, hello. Welcome to Dweens for Teens. This is an introduction to Arduino microcontrollers for high school and middle school students who already have some sort of background in programming, coding, computer science. So if this stuff over here on the right looks vaguely familiar, then we're in business. So for me, as a senior computer science major kind of coming out of college, this was something that I wish I discovered way sooner because I felt like I was picking up all these skills and I was kind of understanding how to program, but I didn't really have anything that I could do with it on my own in terms of a project, right? And I felt like a lot of the stuff you can do with just one machine was, it was kind of boring. So I wanted to branch out a little bit, and eventually I found out about these. This is a microcontroller. It's kind of just a really small computer, and it can execute your code for you. So it's a cool thing to show off. Before we really get into it, there's a couple other things I want to touch base on. First of all, this voice recording, so I apologize if it's not the highest quality. Also, feel free to put the video on 1.5 or ×2 speed because I might not be talking enough and there's certain information that you might want to try to get to. So first thing, I want to introduce the concept of learning because I think that's first and foremost what your priority needs to be, and that'll help you down the line in all forms of computer science and just other studying in general. So a couple of principles to touch on. Don't do more than you need to do, but if something isn't working, learn more. So there's going to be a lot of information thrown at you at once, which is a big thing with computer science. You need to just kind of accept that it's there, and as you get used to it over time, it will make sense and you will understand it better. So if there's certain instructions for this project or for a homework or something, I would suggest that you just blindly follow them, and generally everything kind of works out and makes sense later. But if you're doing exactly what the directions are telling you and things aren't going the way that you wanted them to, that's when you go back and you get a little bit more knowledge and try to see if that helps. And you kind of repeat these two things over and over to overcome obstacles. So the other thing is I'm teaching you to find the information, not necessarily the information itself. There are so many awesome tutorials out there that do a way better job of teaching some of this stuff, and I'm not going to go over it because I think it's redundant. So really, I just want to introduce to you a lot of these topics, and you can go in depth on your own. So if you're already familiar with something I cover, you don't have to learn it at all. But you know, if there's something I mentioned you didn't quite get a good grasp on, I would honestly just look to other resources and try to figure that out on your own, because teaching yourself to learn and doing stuff on your own is a huge part of this, and I think it helps. First of all, understanding Arduino, but also outside of that, just generally a good study habit. Have as much patience as possible. Each bit makes it easier the next time. I will say I am always surprised. These projects have a very weird correlation of effort put in to success. I will sometimes spend hours and hours and hours doing something and get nowhere, and I will sometimes just randomly guess and it will solve my problem. So just know that, you know, every time you get frustrated, each little bit you can kind of push yourself will make it easier the next time you get stuck. So the more you can push yourself in that sense, the easier it'll become over time. And another good skill to develop is finding your own ways to get around dead ends or roadblocks. And part of that is knowing when to give up. And giving up isn't necessarily abandoning the whole project, but you can kind of think of it as, you know, going down certain paths, and some paths just stop. And then you should go back to the last fork, try something else. If that doesn't work, go back even more until you can actually go down a route that works, right? I think a lot of the time people have an idea of what they really want their project to be, and when you're starting it, the very beginning is when you know the least amount of information about how the project will go. So you just need to be flexible. You need to be willing to swap out certain things, or, oh, I need to add this feature, or I have to abandon this feature because it would just take way too long. So be adaptable and find ways that, you know, maybe you've been looking at the same forum for 5 hours trying to find an answer. Sometimes giving it time and coming back to it later is going to help you more than anything. And then the last thing, you should definitely be trying your best to learn as much as possible and experiment, try things on your own, but just be aware of when your safety is on the line. That's the one line you don't want to cross. There's not too many times when this is going to be relevant, but obviously you can seriously hurt yourself if you are not careful with electricity, and also your boards and your equipment, and you can damage that if you wire it improperly. You can give something more power than it's built to withhold, and it could damage it, which obviously you just don't want to be damaging your own stuff. So Google can answer every single question ever. The skill that you develop is knowing how to phrase your question or what you want to know so that Google will give you an answer, right? And also knowing how long you should spend on a page before you kind of make a decision on whether it's useful or not. Because there are some of these issues that come up in computer science in general, but especially with Arduino, where someone will post a problem, there'll be 5 different answers with 5 different solutions, and you just kind of got to go through and try them all, and then eventually something might stick, right? Or maybe it's a waste of time and really your issue's somewhere else, and trying all those things is not going to help you. And the more you do this and the more you practice it, the better understanding you'll have for Arduino, but also you'll have a better understanding of how to Google things. So then you can take that outside of just Arduino and outside of computer science and just use it as a general life skill. I feel like I'm way better at Googling now than I used to be. So the other thing is, if I'm covering something that I think is a pretty general topic that someone will teach you about in school, I'll probably just say to Google it. It's not necessarily me being lazy. There's just no reason for me to repeat work that's already been done by someone else better. And I think a lot of these online tutorials are a lot more clear. And then that way you can customize the amount of effort you want to put in. So a lot of these things I am not going to give too much specificity, especially because our Arduino is so well documented that you can just find a better resource for it online. So learning in itself is its own skill, and I would emphasize that people try to learn how to learn before you learn how to code. And then it works for anything outside of that, right? Like, I think learning to learn is one of the biggest skills that you can have as a college student. So first of all, I want to direct you to this kind of graph on the left, and I think this is how I'd represent like gaining new knowledge, going from the top down. Of you have this first step of this simple thing you know, and then there's 2 new things that you can learn from that. So then when you learn those 2 new things, there's now 4 things that you have to learn. So the more you learn, the more complicated it gets, and it takes all these weird routes where, you know, maybe you put a lot of time into this and this and this skill, and then it kind of tapers off and there's not that much more you can do about it, right? Which is why you need to diversify the categories of things you know, because you never know when there's going to be some connection like this where, oh, knowing this weird thing about how electricity works actually helps debug the issue I was having with the programming, right? There's a lot of intersect in a lot of these ideas and a lot of creative solutions. So the more you learn, the amount that you will have to learn next to improve by the same amount increases exponentially. And I think for a lot of people that can be really demoralizing because it doesn't feel like you're gaining that much knowledge, but I promise when you look back, there will be a lot more than you think there is. Also, learning to deal with failure is, I mean, obviously it's just a life skill you need to pick up, but I think especially with this, there's a way to fail successfully, and as long as you're learning something from it, it can help you with future projects, and it just feels a little bit better knowing that in one way, shape, or form, it's still kind of helping you, right? So the more you can stop from beating yourself up if something doesn't work properly, just the easier it'll be for you to learn. And there's also some really simple projects like this. This is obviously about as simple a circuit as it gets. It just goes in and out. I know I haven't introduced that yet, but just understand that idea. And then there's some really complicated things you can do. Obviously, we're not going to be lunging into building a laptop. We're going to try to keep it pretty simple for the most part. But you shouldn't be doing stuff that you have complete mastery of, and you shouldn't be biting off way more than you should chew, right? I think another idea I'm really going to push is when you learn, you should take things in small increments. So you're always trying to push what you know, but in very small steps, because you can really, if you have this grand idea for this project and you don't really understand how to do it, you're going to find yourself in a lot of trouble down the line. And it's the same when you're developing a project that has a lot of steps. Is I would develop each step one at a time and just test everything so that you know exactly where the error is if something comes up. So abstraction is another idea that I think I want to introduce to you guys. I think a lot of this stuff I like to cover because it's not necessarily so complicated that you need to be some crazy college level student to understand this. I think if you explain it in simple English, that, you know, any middle schooler is going to be able to process what some of this stuff means. But also experience and time kind of help sink in these definitions and the understanding a little bit better. So on the left, I have this picture of a toilet. So the story behind it was there was this artist, already a very well-established artist, who just took this urinal off of a bathroom in New York City and brought it into a museum and called it art, and it was just pronounced art. Just kind of a funny story, and it kind of represents abstract art, but I wanted to get in this idea of abstraction, which is the fact that we can use a toilet without knowing how it works. And that's a good thing that you don't know how it works. Because think about if you had to know how to completely engineer a toilet front to back before you could use it, it would be a major hassle. And I don't really know what the alternative for that would be. So a lot of times there's going to be an idea that I bring up that I'm going to do my best to abstract away from you, right? Because I don't want you to have to go through and understand completely how a toilet works in order to use it, right? I want you to be able to use it first, and then if you want, you can kind of take it apart step by step and understand how it works. So the other similar idea is a black box, right? So a black box is this idea of some magical thing where you give it an input, maybe it's a number or some physical phenomena or whatever it is, and it can just spit out an output. And you don't know how the input correlates to the output, right? Maybe you put in a number and it gives you some other number. But the point is you shouldn't have to know, right? You should just know how to use it. So if you put in 2 and you get 4, you're like, okay, maybe the black box adds 2, maybe it multiplies 2. You don't necessarily need to know that, which is time saved, which is good, right? So you can learn those core skills first and then go back and revisit and analyze it and understand it later, right? So that's why I have this cycle of do, understand, do more, right? Experiment, try things, then once it's working or there's just something that you want to try to understand, that's when you actually go in and study it. So the other point I have here, anything ever can be explained in as much or as little detail as you want. Find a sweet spot. It's why I'm going to keep a lot of my descriptions really brief, because there's a lot of things I need to cover and it's going to take a long time. And again, way better guides online. I just want to really dip your toes in the water of a bunch of different pools. I'm not going to go too into detail about anything in particular. I'm going to try to find that sweet spot of getting you interested, showing it how it can help you, and teaching you how you can teach yourself, right? Because that's the real skill here. So the other one is with development. I kind of touched on this earlier, but you really need to build it up. You need to have something working at each step and build up to the next level. Obviously, you don't have to do it this way, but I've spent a lot of time doing this stuff, and I can tell you that this will usually save you a lot of headaches and a lot of time. So for something like clay modeling, obviously this snail is super simple. You just kind of have this long length, the ball, you stick the ears in. It's not complicated, right? So you start with something that's working like this is a snail, and then you step it up, you do something a little bit more complicated like these elephants here, you know, like you have these little more details with the tusks and the ears, and then you do it a little bit more complicated after that, and then you have your finished product, which is some cool idea that you can show off. You should not try to do this right off the bat, right? Build it up, makes it way easier to understand. You can change the course of the project a lot easier if you find out, oh, I can't do this, or I can do this and it would be cool. So just be careful with that. You'll kind of figure it out on your own too as you play around with it. So the other one that I want to touch on, why computer science is the best thing ever, maybe. A lot of this is my personal opinion, but it's just kind of the way I see a lot of this stuff, is you can take this knowledge that's out on the internet and it's free and there's so much of it, and generally most of it is interesting, and obviously you can be the judge of that, kind of cherry pick what you want and what you don't want. But you can convert that awesome endless stream of knowledge on the internet into your personal knowledge, and this costs effort and time, but it doesn't actually cost any money, which is very helpful because you can kind of do it as much as you want, right? And then you can take this knowledge of the way things work in the world and you can turn it into code, which is generally going to be free, right? Writing code, it's kind of like an idea. Obviously you got to pay for the computer and everything, but most people have access to that. Obviously, if you're watching this video, you have access to a computer and internet in some way, shape, or form. But then you can take this code, these ideas, this high-level knowledge, and you can turn it into money, right? You can make projects, you can get a job, and the more you do it, the more it kind of builds on itself, right? And the whole time you're developing skills that either give you money or can eventually help make you money down the line. Knowing things like how to Google, how to debug a project. There's so many crazy avenues that I would have never thought to try that now, after my time experimenting, I know, and I think it makes me a better programmer and really just a better problem solver. So wanted to introduce that. Absorb what you can. Obviously, you can go back and visit any parts of the slides I've visited already, but now I think we're going to actually get into some of the hard knowledge.